Okay, I don't know about you, but I'm running out of popcorn. Um, so we're going to come back over here. So this is for 10.3, and there's a lot in 10.3, lots of tips and tricks, and I didn't know what was going to be the best thing, so that's why I did the factoring the difference of squares. We're going to put this on page 20. This was one of the hardest things for me when I was a student. I think that's why. Some of them seem pretty easy, but then some of them get a little complex, and I think it was the complexity that sort of drove me nuts. Anyway, so that's going to be page 20, but I'm going to flip back over here first. And so our goal for page 20 is to factor the difference of the squares. Tell me how you feel about that. How do you feel about the difference of squares? Maybe you don't even know what I'm talking about. And then down here, give me a confidence score on that. And then we're going to flip over to page 20. Oops, I already had stuff out. And this is going to be 21. I guess I've been circling them. Difference of squares. So I already made this video once and it got lost. So hopefully I remember to say everything a second time. Hopefully this one doesn't get lost. It's because I'm running out of popcorn, right? I don't have any popcorn, so I'm forgetting what's happening. Or I'm losing things. Okay, so from the video, let's kind of talk about that one, because he did that super fast, right? So he had, what was it, 64y squared minus 49y, and then he kind of came over here, right? And he did x plus 2, x minus 2, and he talked about if we FOIL this out, right, I'm going to end up with negative 2x plus 2x minus 4. I'm going to end up with something where these two middle guys cancel each other out. So you see how negative 2x plus 2x, that's going to be 0. And so what's left is this x squared minus 4. And these are the things that we're factoring. These kind of things. So it's a binomial, but it's, we can still factor it like we would a trinomial. And I feel like that was confusing to me when I was a student. So I'm projecting, I'm thinking maybe you're going to have trouble with that, and so that's why we're talking about it. Okay, so then really what he did though, right, was he just found the square root of both of these. So the square root, and then he talked about how we'll have the two parentheses, right? And then we have a positive in one and a negative in the other. So the square root of 64 is, what's the square root of 64? I think he said 8, right? So I'm going to put that first on both of them. Square root of y squared is y. And then we have the square root of 49, which is 7. So that's how that factors out. Let's look at some other examples though, because again, he did that super fast. Now, again, these are all things that have a negative sign in the middle. If I had a positive sign in the middle, it's not going to factor out like this, because those middle things aren't going to cancel each other out. I have to have one be positive, one be negative. So this is why the difference of squares, subtracting the squares, is the only way that this works. So again, I'm going to have my two parentheses. One's a plus, one's a minus. I'm just going to square root both of these bad boys. X squared, I know that's going to be x. 64 squared, we had it up here. So that's going to be 8 and 8. See? Isn't this easy? Let's look at another example. 9x squared minus 1. So again, these are both squares. I can square root these. I've got plus in one and minus in my other parentheses. So the square root of 9 is 3. The square root of x squared is x. And the square root of 1 is 1. Ta-da! So 3x plus 1, 3x minus 1. I have factored it out. Let's look at another example here. 25x squared minus 16y squared. Again, these are both perfect squares, so I can factor them out. One of my factors is going to be positive, one's going to be negative. I'm going to square root both of these guys. The square root of 25 is 5. Square root of x squared is x. Square root of 16 is 4. Square root of y squared is y. Okay, Heidi, you might be saying, these are still pretty easy. So here's one that's a little bit more complex. 18 isn't a perfect square, is it, right? Neither's 2. There's nothing times each other that is going to, or nothing times itself that's going to equal either 2 or 18. But I can get to perfect squares by factoring out their greatest common factor of 2. So 2x squared, if I factor out a 2 and divide by 2, I just have the x squared. 18, if I divide that by 2, I'm just going to have 9. And look at this. These guys I can find square roots of. So I'm going to do my factor parentheses around it, right? I'm going to put the 2 straight down because I don't want to forget that it's there, but I'm just kind of ignoring it, right? And I'm really only dealing with these guys. The square root of x squared is x, and the square root of 9 is 3. And remember, again, I got one that's a plus and one that's a minus. Okay, Heidi, that one was still kind of easy. Let's really kick it up a notch. I'm going to write this one over here. Example 5. 18m squared n minus 2n to the third. Okay, now, right? Now you're sold. This one's ugly. Again, my terms like 18 and 2, it's like over here. How'd I do that? I picked 2 with the same same numbers. But these aren't perfect squares, right? But what if we go back here to page 17 when we talked about factoring monomials? What if we do this to it? So 18, so that's like 9 times 2, m squared times n, okay? And then 2n to the third, well, that's 1 times 2 times n times n times n. So is there anything that I can take out of both of these? Look at that. I can factor 2n out of both of these things. And then what am I left with? 9m squared minus, so I have 1n squared. And look at that. Like this one was even a third. I can't factor that out in a perfect square because it's a third. That's not, it has to be a 2. But look at that. Now I've got 2 perfect squares. So again, I'm going to square root them. I'm going to put in my factoring parentheses. One's going to be positive, one's going to be negative. The square root of 9 is 3. The square root of m squared is just m. Square root of 1 is 1. Square root of n squared is n. So look at that. Even though that was this big mess of a thing, I could still factor out my my monomial there, that 2n, and I'm left with 3n plus 1n, or 3n and 3n minus 1n. And these ones, you could decide that you didn't want to write them, this should also be correct without the ones in there. Okay, so there's a difference of squares. Again, there's lots of tips and tricks in 10.3. We've got a blank page 21. So if a lot of people are kind of asking questions about the same other thing, that'll give me a good indication that maybe we need some more time with that. I will go back and we'll make another page kind of midweek. So check back with this. I'll try to send out an announcement if I do update the assignment and add another page, but it'd probably just be on a content page and wouldn't necessarily be a part of your week 6 assignment. It would just be something helpful for this 10.3 section. So go work on 10.3. I hope that it goes well. Let me know if something is still confusing, and yeah, go get some more popcorn. Our movie assignment has come to an end, but I still want to eat more popcorn. Okay, you guys are awesome. Good luck with this. Let me know how it goes. And yeah, I'll see you online.